forces within the atom. And what you're going to see here is that there's two topics that we should talk about. One, we have to talk about the discovery of the nucleus, and that was done by Rutherford. And as a consequence of this thing, we should then talk about that atoms are not empty. Even though lots of textbooks would say that, they have no right to make that statement. And what I'm going to do here is that I'm going to show you what I mean when I talk about that. So let's continue with the properties of atoms then. We want to look at the forces. So to describe, the inner workings of atoms, we have to talk about electrical forces. Okay, and this is what we know about electric forces. So there are two types of charges, electric charge. So one of these is the proton. So we call this a positive charge, which is exactly the same as a proton. Then we have a negative charge. And this negative charge is an electron. And this is what we know. What we know is this, is the electrical forces between charges are either this or, so if I have two protons and I put them next to each other, or if I have two electrons and I put them right next to each other, here's what you find. If I have two protons or two electrons, what we know here is that we have a repulsive force between two protons and two electrons. You know, it's kind of hilarious how much the times have changed. Well, here, let me finish this and then I'll make my statement. And then if I have a proton and an electron, they feel an attractive force. So I remember when I was in high school, this was back in the late 70s, they were describing electric forces. They were saying, oh yeah, electric forces are just like people. Males and females and females have repulsive attraction. So that's why they never get together. Whereas males and females, they naturally have attractive forces. Boy, talk about how times have changed. Crazy. Glad to see it. So then what you find here is that when now you look at atoms and molecules, you find that it is electrical attraction that binds atoms and molecules together. You need this electrical attraction to create atoms and molecules. So if I look at my nucleus here, let's say this is my nucleus, and of course I have a series of protons and neutrons. And then I look at the electron shell. Let's say that this is part of the electron shell. And when you look at this guy, this is going to be my electron right here. And of course, this is going to be my nucleus. And when you look at this thing, what you're seeing here is that there's an electrical attraction. Why? Because I have a positive nucleus and I have a negative electron. That's what creates an atom, is these electrical forces. The same is true for a water molecule. If you look at a water molecule, what you'll find here is that we have a nice big oxygen molecule, and then attached to the oxygen molecules, they're attached electrically, are two hydrogen. You're seeing here that this is also an electrical attraction that creates a water molecule. So here we go. So now that I did that brief introduction, the question is this now. How strong are electrical forces within the atom? And I'm going to answer this two ways, okay? And what you're going to find here is that the first way, which is the really important one, is this is known as it's called the discovery of the discovery of the nucleus. And this is Rutherford's gold foil experiment. This is a very, very famous experiment in physics. So the way it works here is that Rutherford at this time, he had most of his career in England, but for a period of time, he worked in Canada. And so Rutherford and friends, and what I mean by friends, I mean graduate students. It was the two graduate students were Moseley and Marsden. So Rutherford and friends discovered the nucleus by firing, maybe I shouldn't say firing, but shooting what are called helium ions. And a helium ion is literally this guy, but it has two missing electrons. And this thing, because Rutherford did not know what it was, he called it an alpha particle. Later on, he figured out what it was, But by that time, nobody had ever seen this helium ion in this capacity. So he discovered the nucleus by shooting helium ions or alpha particles at a very thin gold foil. Now, I don't know if you've ever played with gold foil. Gold foil is extremely thin. I mean, if you blow too hard, you will rip it. It's that big of a deal, okay? So you will literally rip it if you blow too hard. So here's the setup for the experiment. So what he did here is he had a gun, and this is a helium gun. So that means this gun would shoot out little particles. So you're seeing shooting of these guys here. So we're going to focus on the first one, but there's these other ones right here. So these are the helium ions. These are the alpha particles, and these guys are definitely moving very fast. Because they're coming out of the nucleus, you find that they have, so these are very energetic, which implies that they have a large kinetic energy, really high kinetic energy. So there's your helium gun. And then what he does here is he shoots this directly at a gold foil here. So you could imagine that this guy here is the gold foil. So the question is, what did Rutherford expect to find in this experiment? So maybe I should really back up a tiny bit here. The first model of the atom was created by a guy named Thomson. And he had what was called a plum pudding model. And the model was essentially, you had this very thin pudding, and then electrons were scattered. And those were the raisins in this pudding right here. So what he expected to happen is that these very energetic particles were just gonna shoot right through this morass, I guess, by Thomson. So to answer the question then, he expected the alphas or alpha particles to rip right through it, right? Maybe I should have written it a different way. Rip right through it with no interactions. And the reason why is the kinetic energy of these alpha particles were just going to go, and it would just push the electrons right out of it, no problem. Here's what happened. Actually, I think I want this picture right here. So to Rutherford's surprise, some of the alphas were deflected right back at the gun. In other words, they were deflected by 180 degrees. So when you look at this thing here, here's what you find. So if I was to paste this guy right in here again, here's what you get here. So I'm going to only focus on the green one. And so what you see here is that this green one, let's say it was coming in here, and then what it would do here is it would literally come in here and it would never make it to the gold foil, and it would be deflected just like this. This was a shock, right? So you're thinking you're shooting something at tissue paper, and then all of a sudden, something that's super fragile, super thin, should never, deflect something back like this ever. So what happens now? So what happens here is that it's Rutherford's analysis that was quite impressive here. And here we go. Here was Rutherford's analysis. And what he said here is that, check this out. So I have two atoms that I want to bring in. Oops, that did not come in. Here, let me get the other one. Thought I. So here's the two atoms that we want to look at. So remember, not all these details were known beforehand. And so what you're seeing here is that this is gold and this is helium. So what you're seeing here is that the atomic nucleus has 79 protons. Whereas in this case, it has 2 protons. So what his picture was is this. He says, okay, so I have a nucleus, right? So I'm looking at my nucleus, and I'm only going to focus on the positive charges. So there's this enormous amount of positive charge. So this guy has 79 protons. And what happens here is that as this proton is coming inwards, right? It's coming in. What it's doing here is that this proton, or helium nuclei, excuse me, right? This is the alpha particle coming in. As it's coming in, what it does here is that these 79 protons produce an extremely intense electrical field. So this here is the gold protons producing an extremely intense electrical force field. And so what happens here is that when you now go look at this here, the alpha particle, it's the alpha is repelled by this intense force field. And that's why when it comes in, it never gets even close to the nucleus because it's getting repelled. So around the nucleus is this huge. And Rutherford's quote, in my opinion, is one of the best I've ever seen. This is Rutherford's quote on this experiment. He says, it was almost as incredible as if you fired a 15-inch shell. By the way, what was the 15-inch shell in this case? This was the alpha particle. Because remember, these were really energetic alpha particles. As if you fired a 15-inch shell at a piece of tissue paper. And what was the tissue paper? It was the gold foil, right? It's super fragile. And it came back and hit you. This is how Rutherford discovered the nucleus, right there. And he won a Nobel Prize for it because nobody knew in 1910 that there was a nucleus.